Hey folks, how's it going? In this video we're going to go over question 1 from the 2017 SQA Advanced Higher Physics exam paper, so let's get into it. Question 1 says an athlete competes in a 100 metre race on a flat track as shown in figure 1a, and it says starting from rest the athlete's speed for the first 3.10 seconds of the race can be modelled using the relationship v equals 0.4 t squared plus 2t, where the symbols have their usual meaning. So that would mean v is velocity in metres per second and t is time in seconds. It then says, according to this model, for part A, determine the speed of the athlete at time t equals 3.10 seconds, and you'll see there's 2 marks available. Well, we're already given an expression for the velocity v, so let's just sub in the time value to find what v is. So we want to substitute the time value into the expression for v, so if we start with v equals 0.4 t squared plus 2t, then we can substitute in t equals 3.10 seconds, so that becomes 0.4 times 3.10 squared plus 2 times 3.10, and putting that into your calculator should give you an answer of 10.0 metres per second. Part B says to determine using calculus methods the distance travelled by the athlete in this time. Well, remember we were given an expression for velocity, and if we want to determine an expression for distance or displacement s, then we need to integrate rather than differentiate. So we want to integrate the velocity v with respect to time, so we can write v equals ds by dt is equal to 0.4 t squared plus 2t, where all we're doing is including that v is equal to ds by dt, which is on the relationship sheet. And that means we can sort of ignore this v part now and just deal with the ds by dt is equal to this expression. So we want to integrate both of those with respect to time, so we have the integral of ds by dt dt is equal to the integral of 0.4 t squared plus 2t dt, where the brackets are used to show that we're integrating both parts of this expression. So for the left hand side, integrating velocity with respect to time will give us displacement s, so we have s is equal to, and then remember to integrate these parts, you want to raise the power by 1 and divide by the new power. So we have 0.4 t cubed divided by 3, plus 2t squared divided by 2 plus c, where c is our constant. And then we could simplify this part a wee bit, so we get s equals 0.4 t cubed over 3 plus t squared plus c, where the 2's there are just cancelling out. And to find out what this constant c is, we need to consider the initial conditions, which remember is just what happens at time t equals 0. So we can say that at t equals 0, the displacement s equals 0 because the athlete hasn't moved yet. So if we sub t equals 0 into there and s equals 0, we get that c is equal to 0. So that means we can ignore the c and simplify s to s equals 0.4 t cubed over 3 plus t squared. Now at the end of part B it said in this time, so it means the 3.10 seconds that was mentioned in part A. So lastly we want to substitute the time value into this expression. So we have s is equal to 0.4 times 3.10 cubed over 3 plus 3.10 squared. And if you put that into your calculator you should get an answer of 13.6 metres. That's all for this video folks, thanks for watching. If you made it to the end I really appreciate it. Make sure to give the video one of these, subscribe to the channel, and I'll see you in the next one. Take care.